Hey everyone, welcome back to 197 Concepts. In this video, I am going to discuss with you how to find whether a given number is a positive number or an even number. Okay, so let's jump into the video without any delay. So you can see in front of you the screen that it consists of the program to find whether the given number is a positive or even number. But before jumping into this program, I'm going to jump to some other program so that we can discuss some basic things regarding to this program. Okay, yeah. So before knowing to the program, you have to understand what are odd and even numbers. I hope you are very familiar with the odd and even numbers. So I'm not going to define you what the odd and even numbers are. I'm just going into the logical forms of any given number. Okay. So we know that definitely the odd numbers. Let me change the color. So we know that the odd numbers are, if you just go roughly, the odd numbers are 1, 3, 4, not 4, 1, 3. Yeah, we do have undo here. So 1, 3, 5, 7, and 9, right? And the even numbers are starting with 0. Then what we have is 2, 4, 6, 8. Okay, so I'm taking up to 10. That's it. That's it. Up to 10. Above 10, all these numbers are going to repeat. I'm not talking about those. So let us write all the numbers one by one in the binary form. So this one is 0001 and 2 is 0, not 2, I'm going with 3. So I'm separating odd and even numbers. So this is 0011. Then what we have is 5. For this, we have 0101. Then we have 7, which is nothing but 0111. And the number 9, which is 1001. Okay, so these are the odd numbers and the even numbers is 0. Starting with 0, all zeros. Then starting with 2, we have 0010. Then starting with, then the next number is 4, which is 0100. And 6, 6 is 0110. And finally, the number 8 is 1000. Okay, now what you have to observe here is observe this this bit of all odd numbers and all the even numbers, irrespective of what you have on the left side of those bits. So if you observe this, this is the LSB of all 8 bits and this is the LSB of all 4 bits. Sorry, not 8 bits, all 4 bits. If you observe here, all the even numbers, all the even numbers has logic 0 in their least significant bit, whereas all the odd numbers has logic 1 in their least significant bit. Okay, so this is the base of our program. So if I have randomly, let us say 87, if I write this, then I have 1000 and 0111. I don't want this complete number. I'm just going to focus on this LSB. Okay, let us take green color. I'm going to focus only on this LSB. If it is logic 1, then it's a odd number. Okay, if you take the example of say 90, random number, okay, 90, then what we have, if you write this in binary form, it's 1001 and then all zeros. Observe the most least significant bit. This is definitely logic 0, so it's an even number. Okay, now, so that's the basic idea. And in order to check this in the program, what we are using is, again, we are going for the, so again, we are going for the we are going for the test function. So, like I have told in my previous video of checking whether a number is odd or even here also, you can check that video. I will give the link in the below description. Okay. So here, what we are doing is we are using the test function, which will do the logical and operation. So for example, and the number that I'm going to choose is I'm going to choose 0, 1. Okay, there I have used another number, and here I'm using the 0, 1 because 0, 1 is the only number that give me all zeros except the least significant bit as logic 1. So I'm focusing on only LSB. So this should be 1 because I'm doing logical and operation. If I'm going to do logical or operation or any other operation, definitely it's not going to satisfy me the output because logical and is the only operation where you get a logic 1 as an output for both the inputs when they are high. Okay, it's the only operation. That's the reason I have to do logical and that's the only reason that I have to select the number 0, 1. So check out the other video. You will get a clarity why I have used this specific number. There I have explained why we have used another number for doing the same test operation. Okay. Yeah. Now, coming to our examples, let us take some examples, random examples. Okay, like in the previous page, what I have used? I have used 87 and 90. Okay, so I'm going to use 87. So 87 binary form is 1 0 0 0, and for 7 it's 0, 1, 1. Now the number that I am going to take for comparison is definitely for doing the logical and operation is 0, 1, and its binary form is this. Okay, now I have to check the result. So when I check the result, what I'm going to do, I'm going to do logical and operation. So both are logic 1. So this one is logic 1 and all the other are 0. This is the result. Okay. So when you have considered this result, now what you have to do is you have to check the least significant bit. When this significant bit is logic 1, I don't care all these bits, whatever there are, I don't want those bits. I only need the least significant bit. Since it is at logic 1, definitely it's an odd number. You can observe that here also. Okay. Now, if you take the example of 90, okay, I'm going to change the page. If you take the example of 90, so 90, write the binary form, it's 1001 and 0000. Then I think I've used the green color for 0, 1, then it's 0000 0001. Okay. Now, what I have to do? I have to do the logical and operations in order to get the result. Okay. So, what I'm going to do? I'm just going to do the logical and operation, which will give me here all fours and here also zeros. Okay. So, since the least significant bit is 0, this least significant bit is at logic 0, definitely it's an even number. I hope you have got a clarity of how I'm using this least significant bit, whether to check a given number is even or odd. Now, our main task is to check if the result that I have received, based on that, to tell whether a number is odd or even. Okay, so this is possible. The possibility of checking the least significant bit is available, or it is possible by doing this manual calculation. But system is not able to show you this manual calculation. Okay, so we have to find a way where we can tell the system, where we can tell the system to check if the least significant bit is 0 or 1. For that, we have to jump into the program. See, we are using JZ. Okay, we are using JZ command here. Yeah, we can use here two commands, not only JZ. In the program, we are using JZ. We can use the JNZ also. Okay, so JNZ means jump if 0. Okay, and JNZ means jump if not 0. So basically, the meaning of these two things, these two commands, is nothing but if you are doing if you are doing any operation, be it addition, subtraction, multiplication, whatever it is, if the result, as in this case, if the result of any operation gives you 0 of all bits, so here I'm using 8 bits. If my 8 bits are 0 for any operation, then the the zero flag of 8086 processor will go high. That means I will get one logic. Okay, or else you can say I will get logic 1, logic high. This tells that my result is 0 and it will satisfy the condition JZ. Okay, so jump if 0. If the result of the operation is 0, or else you can say that if the result of any operation makes all the bits are equal to 0, all the 8 bits or 16 bit, what number of bits you're using, whatever the number of bits you're using, if all the bits are equal to 0 and they're at logic 0, then definitely you can jump to a specific label. So JNZ is opposite to that. If any one of the bit out of these 8 bits, if any one of the bit is at logic 1, for example, here we have, yeah, in this case, since here the least significant bit is at logic 1, you cannot tell that all the 8 bits are at logic 0. That is when you are satisfying the condition of J and Z. So jump, you are going to jump. Definitely you're jumping to a specific label. But when? When you have a result that is not equals to 0. Okay. So if you convert this into the hexadecimal form, this is 0 and this is 1. But when you convert this into a hexadecimal form, this is 0 and this is 0. Okay, that's the main thing of the program. That's the main logic and all. And if you have understood this, I'm jumping to the program, and this is easily understood. This will be easily understood by you if you have understood that logic. If not, I recommend you to rewind it and watch it again, because that's the base point of our program. So these are the starting lines. Yeah, I have minimized this. That's why I'm getting a cursor. So these are the basic starting lines of our program. These are the ending lines of our program. This is the condition where I'm telling to move 0 0 if the number is an even number, and 0 1 into the AH if the number is odd number. Then jump directly to this part of the program instead of executing this line. Skip this line. Okay. The whole magic happens at this line and this line. So first of all, I'm moving 54H into the accumulator register. Let me write here. So 54 is, so what's the binary form? 0101, and 4 is 0100. Now, the next is 01. Testing condition is 01. So 00000001. Now for this, I have to do the logical AND operation, which will give me 00000000. Okay. Now what I'm going to do is I'm just going to observe this LSB, since it is logic 0. Okay. Logic 0. I get a clear idea that 54 is an even number. I have gotten clear idea. But in order to tell that you have to execute these lines, what I'm going to do is I'm going to check if this result is equal to 0 or not. When you convert this in hexadecimal form, this will be the complete result, 00H. Since it is 00, your 0 flag will go at logic 1. This will tell you have a 0 result. Then this condition, JZ condition, is met, and I will change the color just a minute. And This condition is met, and your program will jump, instead of executing these lines, it's going to jump to this statement, that is even statement, and it is going to move 00h. Okay, while programming, I'm going to change this value from 00h to 02 in order to understand the value, because if you have initially 00, again it will be overwritten with 00. Okay, so now my plan is, I'm going to take two numbers. The first number will be 54h as it is. Okay, and the next number, what I'm going to do is I'm going to take 53h. Okay, I'm going to execute these two only in the one program, within the one program. Oh, yeah, that's the wrong spelling. I'm going to execute both of this in one program. Let me try it. Okay, so how could I club those? Yeah, I have to write these statements again after completion of this line. Okay, so that's a programming part, and let us do that there. So I'm just selecting all this, copying it, and opening DOSBox. Okay, so F11 and F11 and F, that will shift this to, oh wow. Yeah. So CLR and mount CC backslash, then next C backslash, and CD 8086. Okay, now edit and paste. So what I'm going to do is I'm going to initially execute these two as it is. Okay, so file, save as, uh, this is order even, right? So EU, let's keep the name as EU ASM. Okay, so that's even or odd. Now what I'm going to do is I'm just simply going to execute this mashup EU dot ASM semicolon. Yeah, we have one error. Yeah, even. Uh, so even, what's the line? Line number 13. So even is a built-in function which you cannot use here. So what I'm going to do is I am going to type another EV. Okay, instead of N, I'm going to type E again. So I have to save this. I have to exit from here. Masm EU dot ASM. So no errors. Now I'm linking EU dot OBJ. Yeah, linking is complete. AF debug EU dot exe. Yeah, just keep an eye on the zero flag and see here when I press F1, the accumulator register AL is going to be updated with 54. Now this is going to be tested with 01. If you see the zero flag, it has changed to logic 1. That means my complete result of doing the logical AND operation, that between the values present in AL and 01 is 0. Now I have to jump to the label, that is, I have to jump to the address which is 000p. If you check where that 00p is, 000b is, that's B400. Now I have jumped to B400 and the AH will give you 0. So this does not this has not given me any change in AH, higher byte of accumulator register, because previously they were 0. So that's why what I'm going to do is I'm going to change the value of that particular thing. So edit, and when it is even, I am going to change this as 02. So file, save. So it's the same number again. Let's do the shortcut. Amazon. Now link. Now AF debug. So 54 has shifted. Testing 0 flag. Observe it's 0. Now it's logic 1. Now it's going to jump at 00B, 000B, and it's going to give 02. Okay, that means our number what we have taken is it's an even number. So I'm going to quit from here, and now what I'm going to do is I'm going to change this value to 53. Okay, so alt save exit nasm link af debug 53. Observe 0 flag, no change. So jz is not satisfied, so that's why I'm getting 01. Okay, I hope you have understood the basic programming part of how to find whether a given number is even or odd. So in the next video, I will try to tell you how to execute both the logics flawlessly. Okay, that's it for this video. Hope you have understood the topic. Thank you.